The second half of Topic 6 continues with logarithms. We're going to look at properties of logarithms and utilize them as a method for solving. As we look at properties of logarithms, we're going to start with three of them: the product, quotient, and power properties. These properties work for both log, for log and ln logarithm definitions. We have the product, quotient, and power. The product property takes a compound logarithm that has a product, and it splits it into addition. The quotient property has a fraction and splits that up into a subtraction of logarithms. And then we have the power property when you have an exponent. And what that does is it puts it out in front as a coefficient. We'll start off by using these properties to expand and condense logarithms, and then eventually we'll look at how to use them for solving. When you're asked to expand a logarithmic expression, what you want to do is you want to use your properties to separate anything that has multiplication, division, or powers. You're using your definition from left to right. So the definition applies from left to right. And you'll have more than one logarithm in your answer when you're done. So let's give these a try. Example 1. It says in the directions to expand. Expand each expression as a sum or difference of logarithms. That just means we're going to split them up and add and subtract in our final answer. Example A, log base 5 of a to the second times b to the 7th. We have a couple of things happening here. We're multiplying bases a and b, and they both have exponents. That means we'll apply the product and power property. The product property we'll do first. We're going to separate the a and the b into addition of separate logarithms. So what we'll do is we'll just split this up into log base 5 of a squared, and then plus a second logarithm, same base, of b to the 7th. That's splitting up that product. But then we have powers, or exponents. And what we'll do with those exponents is we'll take the power itself and we'll apply that power property. Put it out in front of the logarithm as a coefficient. So now it's 2 times log base 5 of a plus, and then we'll do the same thing with the 7, but the 7 is going to go right in front of that second logarithm. 7 log base 5 of b. So we expanded the expression using the sum of logarithms. Let's try the second one. ln of the fraction 25 thirds. When we have a fraction, that's the same as a quotient, and we'll separate that fraction into a difference of logarithms. That means we'll take ln of the numerator first, and then we split it up using subtraction. We'll subtract the ln of the denominator second. Recognizing that if it's ln, we know that ln is base e, therefore we don't have to write that out. From there, that's as far as we can go. See if you can try example C. Log base 7 of r cubed times t to the 4th divided by v squared. Separate that into an expansion of the sum and difference of logarithms. Then press play and we'll see how you did. Let's see how it went. If you notice that you have r cubed times t to the 4th on the top of that fraction, that's a product. And we expand a product using addition of smaller logarithms. But because it's in a fraction, that's technically the quotient for the denominator, and that means we subtract. I split this up into log base 7 of r cubed plus log base 7 of t to the fourth minus log base 7 of v squared. Then applying the power property last, taking each of those exponents, putting them out in front as coefficients. We've expanded that logarithmic expression. Let's try one more. Log base m of 1 divided by a to the fourth. Again, we've got a quotient, so we'll split that by subtraction. Log base m of 1 minus log base m of a to the fourth. Well, here's where we have to think about something from the last chapter. Log base m of 1, even though the base is m, log of 1 is kind of significant. That's going to always equal 0 because m to the 0 power equals 1. So that answer just cancels out to be 0. Anytime you have log or ln of 1, it's always going to just default to 0. But then we have our a to the fourth. I'm going to take that 4 and put it out in front as a coefficient, times log base m of a. Well, 0 minus 4 log m of a, the 0 really doesn't need to be there, making our final answer simply negative 4 log base m of a. The reverse of expanding would be to condense. When you're asked to condense, you're going to use your properties backwards, which means you'll have examples that look like the right-hand side, but you want to condense them down to look like the left-hand side when you're done. And the key for condensing is you don't want more than one logarithm or ln in your final answer. So that means only one log or ln in your final answer. So let's take a look at some examples on the right. Write each expression as a single logarithm. When you see this set of directions, that means you're going to condense the expression to one term. And we work backwards with our properties. Now we look at coefficients first. Notice I have a 4 in front of log base 4 of m. That's going to go backwards as an exponent. I have a 3, that's going to go backwards. And then there isn't anything in front of log base 4 of p. Therefore, the first thing I'm going to do is just rewrite these expressions with powers instead of coefficients. That will give me log base 4 of m to the fourth power plus log base 4 of n cubed minus log base 4 of p. Now we'll take a look at the addition and subtraction. Anytime you have addition, what you want to do is condense the terms using multiplication. So we're going to multiply those together, and that will condense the two logarithms down to 1. It'll look something like this. Log base 4 of m to the fourth n cubed, just side by side like that. And then we have subtraction log base 4 of p. To condense the subtraction, what we'll do is we'll take the 2 terms and the 1 term on the left, and now we'll treat them like a fraction and divide. When we're done, we're only going to have one logarithmic prefix, base 4, and it's going to be of the entire fraction, m to the fourth n cubed all over p. There's condensing to one logarithmic term. Our next example has 2 subtraction problems, and we'll get to that in just a moment. But first, let's look at our coefficients out in front. Again, anytime you have a coefficient, make that an exponent or a power. And we'll do those parts first. This gives us ln of 2 to the third power minus ln 5 squared minus ln y. When it's 2 to the third and 5 squared, we can actually evaluate those. We know what 2 to the 3rd power is. It's 8. We know what 5 squared is. It's 25. And then we'll leave ln y. With the subtraction for both parts, what we'll do is we'll keep this in the numerator, and we're going to divide. Wow, I don't even know what that word is. So we're going to divide both parts. I know, that's kind of crazy. That'll give us ln in the numerator just 8. But because we're subtracting the 25 and subtracting the y, they both go in the denominator. And there you go. Ooh, and the birds outside agree. That will be the way to do it. For our last example, we have 2 times the parenthesis log base 3 of 20 minus log base 3 of 4 plus 0.5 log base 3 of 4. Now, thinking order of operations, we'd want to condense the parenthesis first. Wow, where are my words coming from today, you guys? I don't even know where that was, what that word was. There we go. That should be condensed right there. And I'm just going to rewrite it because that looks like an M. Okay, let's condense. All right, there we are. We have subtraction. And how do we condense subtraction? We make this a quotient. Then that gives us 2 out in front, log base 3 of 20 over 4, plus 0.5 log base 3 of 4. Now, if we have log base 3 of 20 over 4, we can simplify that quotient to be 5. And once we know that it's 5 and it's just one logarithmic term, we can eliminate the parentheses. And then we have plus 0.5 log base 3 of 4. Now that the parentheses are gone, it's kind of business as usual. Let's take that coefficient and make it an exponent or power for each of those logarithmic terms. Log base 3 of 5 squared plus log base 3 of 4 to the 0.5. Well, let's try this again. 5 squared is 25. Log base 3 of 25. How many of you remember what 4 to the 0.5 power is? 4 to the 0.5 power is the same as 4 to the 1/2. And 4 to the 1/2 is the same as the square root of 4, which is 2. Now, let's take a look at condensing that addition problem. We can condense addition by multiplying the 2 parts for the original, or the expanded logarithm. That means we'll do log base 3 of 25 times 2. And voila, 25 times 2 is 50. This condenses down to log base 3 of 50. And there's utilizing those 3 properties, the product, quotient, and power, to expand and condense. We'll end today's video with an application problem. Example 2. The pH of a solution is a measure of its concentration of hydrogen ions. The concentration, measured in moles per liter, is written as H+, and given by the formula pH equals log of 1 over H+. What is the concentration of hydrogen ions in the acid rainfall? Taking a look at the different pH solutions in the chart, we've got orange juice, acid rain, clear rain, and a healthy lake. We want to know what the concentration of hydrogen ions is for acid rain. So we're going to use the pH number of 4.5. Based on the formula, the pH equals log of 1 over H+, H+ being the ions. If we set pH equal to log 1 over H+, our pH is 4.5. We'll take 4.5 and set it equal to log 1 over H+. And our goal is to get H+ by itself. What we'll do is we'll expand first our quotient. We expand quotients by subtracting. And that will give us H plus out of the denominator. Now we've got to kind of figure out from here what to do. And this brings us back to our last topic on how to solve equations. Recognizing that log of 1 is 0 because 10 to the 0 power equals 1, what that allows us to do is kind of eliminate that from the problem altogether. 0 minus log h plus is just going to be negative log h plus. Now what we'll do is isolate the logarithm, which means we need to divide both sides by negative 1. And I'm sorry I ran out of space right here. We'll go move it over here to this bottom part and we'll get it figured out. And now my cat is talking to the birds, so hang on just a moment. All right, let's keep going. 4.5 divided by negative 1 is negative 4.5. On the right, we have log of h plus. Now our log is base 10. In order to solve then, what we'll do is we'll convert this to exponential. We'll start with base 10, and then we'll raise it to the negative 4.5 power. Oh, there's a negative in there. Can you guys see that? There we go. And that should equal, when we loop it back, our h plus. And that's ultimately what we were solving for. To get h plus by itself, let's take 10 to the negative 4.5 power. And if we do that, we're going to get a very small number. 0. Looks like 4 zeros, 1, 2, 3, 4, 3, 1, 6, 2, 3 milliliters, or not milliliters, moles per liter, moles per liter. That would be the amount of hydrogen ions in acid rainfall. And that's where we'll end our video lesson for today.